Example M6.3. For a short time, the crane lifts. The crane in the figure lifts the 2.5 megagram beam with a force of 28 plus 3s squared kilonewtons. Determine the speed of the beam when it has risen 3 meters. Okay, and also how much time does it take to attain this height starting from rest. Okay, so since we are supposed to we are asked to determine the speed and the time. Uh, when talking about speed, we can determine that with simply the principle of work and energy. But for the time, takes us it takes us going back to our kinematics equations in order for us to determine the time. So before we can apply the principle of work and energy. First, we have to determine the work done on the system, and to determine the total work done on the system, we have to determine the forces acting on the system. So we have to draw out the free body diagram. But in this figure here, there are only two forces, namely the variable force with that changes with respect to the displacement s, right? As it goes higher, then the force goes higher as well. And then we have the weight here, which is 2.5 megagrams. So that is megagrams is 1,000 kilograms. Okay, so that is 2.5 times 10 to the 3 times 9.81 newtons. Okay, so that is mg. Okay, so since we have the free body diagram and we know the forces acting on it, which are the variable force and the weight, then we can calculate the work done by each force. Okay, so this is supposed to be by, and then therefore the work done by each force is for the variable force, since our force changes with respect to to s rather, then you have to integrate with respect to s as well. So from 0 to 3, the integration integrating from 0 to 3, the equation 28 plus 3s squared, and since this is in kilonewton, you have to change it into newton in order for us to arrive at a unit of newton per newton meter, which will translate into joules. Okay, so then we have 111,000 joules. Okay, after integration from 0 to 3. Now by weight, well, weight is just the work done by the weight is basically just weight times the change in position with respect to the y-axis. All right, so this is essentially negative because it is going against the motion. Okay, because we want to bring this weight up while the weight this beam up while the weight is pulling it down. Okay, and we take the reference point as well here. We take the reference point here as s equals 0 meters. Okay, so that is the reference point. Okay, so after having determined the work done by the forces, we can then apply the principle of work and energy, which is the initial kinetic energy plus the sum of all the work sum of the sum of all work done on the body is equal to the final kinetic energy. And therefore we have 1/2 mv1 squared plus the total work done on the body equals the 1/2 mv sub 2 squared. Okay, since we know it starts from rest, v sub 1 is 0. All right, and therefore we can solve for the final speed, which is v sub 2, and that will come out to 5.47 meters per second. So an alternative way to determine the velocity at any position s is to apply the principle of work and energy to the quantities of work without solving at a specific position. That is to say that we just input this integration, right? And integrate with respect to s into the principle of work and energy. Okay, so that is why we have here 0. Again, this is 0 because we started from rest, plus the integral from 0 to s of 28 plus 3s squared times 1000 newtons ds. Okay, and then minus 2500 times 9.81 meters per second squared times s, okay, equals the final kinetic energy. So v sub 2 in terms of s is the square root of 2.78 s plus 0.8 s cubed. Okay, so applying kinematics, since we want to find the time it takes to attain this height starting from rest, we know that velocity is essentially just the change in position with respect to time. Okay, and so if we plug in the equation for velocity, or the expression for velocity that we got here, all right, into this differential equation, we will have dt is equal to ds over the square root of 2.78 s plus 0.8 s cubed. Okay, so we can then integrate both sides. So integrating the left side from 0 to t and integrating the right side from 0 to 3, we will have a time of 1.79 seconds.